Okay, so yesterday we did 7.1, 7.2, A1. We only got halfway through part one. Okay, where we talked about the exponential function, and we talked about what denotes an exponential growth. A or B has to be bigger than 1. And exponential decay, B has to be a fraction between 0 and 1. We talked about the horizontal asymptote. We did quite a few example problems where we found the y-intercepts, domain range, and then the end behaviors. And then we looked at what a number, when my a was greater than 1, it actually made, when it's positive, it made my graph narrower. And then we talked about the negative a. Negative a flips it, but because we have a negative in front of it, the negative gets smaller and my graph gets narrower. Then we did another example. And then I showed you guys that you had to be careful of negative exponents. It actually looked like a growth problem, but then because of the negative x, made it a fraction, which now is okay. Deal with it. Today is 7.1, 7.2, part 1, a number 2. Okay, and today is what? Tuesday, February 26th, in the year of our Lord, the 2016. Okay, what we're going to discuss today is transformations. Okay, our transformations, just like we learned all of last semester, our transformation here is, of course, minus h plus k again. Now, notice that our h is like inside that mathematical symbol thing, right? Okay. So what's going to happen to the direction? First of all, is it going to move left or right? My h tells us left or right. And it's opposite sign, right? Hey. And my k tells me what? Up or down. And it follows the sign, right? All right, so let's take a look at this example problem here. My problem is we have this function y equals 3 times 2 to the x minus 1 minus 4. Okay. Before we even graph this, we're supposed to compare it to y equals 3 times 2 to the x. So, what are my transformations here? Okay, we're down how many? 4. Down 4. And what about my h? Right 1. Right 1. My h here is opposite sign here. So it's right 1. Minus 1 is a right 1. It's actually positive one, which makes it a right one. But just go opposite signs. It's what we've been doing, and that's what we're going to do. We know the domain, right? What's the domain for all these exponential functions in this course? Negative infinity, positive infinity. Okay, can we get anything else without graphing this? Sure. No, we're going to have to graph this. All right, so grab your calculators. James, shut up. Shut up. Okay, go to your y equals and put in 3. Shut up. 3 times 2. Now, anything attached, if you have anything attached to the variable in your exponent, you better put it in parentheses, okay? So raise to the parentheses x minus 1, and then minus 4. Graph it. Okay, so let's put in our points. Go to second graph, get your chart. Negative 3 is negative 3.813. Negative 2 is negative 3.625. Negative 1 is negative 3 1/4. Zeros, negative 2 1/2. 1 is negative 1. 2 and 8. Let's graph those. See, negative 3 and really close. Oh, negative 3, negative 3. Really close to negative 4. And again, pretty close to negative 4. And negative 3 1/4. A little closer to negative 3. Negative 2 1/2. There's my y-intercept, right? 1, negative 1. 2, 2. And 3, 8. What? What? It was wonderful. I thought I told you that yesterday. I forget in 24 hours how my weekend was. Hey, what's that horizontal line I drew there? Yeah, that's my horizontal asymptote. Oh, James asymptote, that's right. Actually, somebody else claimed that yesterday. Was it Greg? Greg asymptote? I am so happy I'm recording. Okay, so what's my range here? Oh, by the way, what does asymptote mean? It means my function gets really close to this line, but never touches or crosses it. And this line's equation is what? Negative 4. Very good. Very good, Blake. Y equals negative 4. So it never touches negative 4. Are you seeing a pattern? Huh? 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 Are you? Are you? Are you? Are you seeing a pattern? Okay. What's your K here? What's your K? K is negative 4, right? What's my H, by the way? H is positive 1. Because my H in the equation is negative already. Okay, so I see that my K is -4 here. I see that my horizontal asymptote is -4. What do you think the range is going to be, my least value? -4. Wow, you guys are super smart. But it never touches or crosses it, so it's parenthesis. Where's my H going to? I mean, my Y. Positive infinity, right? Anything else we got to do? I think that's it. Wow, that's highly impressive. It's colorful and impressive all at the same time. You got a question or just a dumb remark? What? Because my function here, it gets real close to -4. In fact, it keeps dividing. This one, it looks like it divides by thirds. And it just keeps dividing by third, by a third, by a third, but it'll never get to -4 as far as my range, okay? All right, are you ready? Oh, it was so terrific. Now I'm going from the f of x, 4 to the x, to the g of x, 4 to the x minus 3. What kind of shift do I have here? Down 3. What's my domain? Wonderful. And what's my range? -3, infinity. Wonderful. Okay, number 11. I'm going from 3/4 raised to the x to 3/4 raised to the x minus 1. What's my shift? Right 1. Okay, opposite sign. Domain? What's my range? What's my k? What's my 0? Okay, I'm adding 0 to this. That's my k. And it's going up to infinity. Okay, number 12. I'm going from 9 to the x to 9 to the x plus 1 minus 2. What's my shift? Domain? What's my range? See how easy that is? Question? Yeah, what are you doing? Goldfish? Oh, the crackers. Part 2, or goal 2, using exponential growth and decay models. Okay, when a real life quantity increases by a fixed percentage here, your interest, cards, credit cards, right? Or other period, the amount of y of the quantity after 2 years can be modeled by the equation y equals a times the quantity 1 plus r raised to the t, where a is the initial amount. That's important. I like that. R is the rate. I would highlight that too. R is the percentage rate. And T is time in years. Okay. Now, if I had a minus sign in the decay or growth factor in this factor here, this one I had a plus, this one's a minus. So what do you think this one is? That's right, decay. You ready? Are you ready? Huh, kids? Huh, kids? Huh? Huh? Okay, number 13. A scientist estimates that a specimen begins with 730 bacteria. What's that? What's 730? It's my A. If the specimen grows by 35%, what's that? R, I'll make it purple. Every minute, write an equation that represents the bacteria's growth. All of a sudden, they're changing our Y's to a capital A. I don't like that. Put your Y there. So Y equals is growth, right? Grows. So we're going to use this top one. Y equals A. What's my A? Times quantity. 1 plus, what's my R? In math, we don't like the percentage thing, so we change it to a decimal, 0.35. And do we have the actual time over a period of time? It says every minute, but that's not the actual period of time. So we're just going to have to leave the T there. Find this? All right. How many minutes? So now we're looking for T, right? How many? So we're looking for T equals what? Looking for T. How many minutes will pass before the bacteria reaches a population of 9,000? What's 9,000? If this is my T, I've got A, I've got R, I've got T. What do you think the 9,000 is going? Where am I going to put that? I already got A. A is 730. T we're trying to find. So T is taken care of. It's got to be the Y, right? This has to be my Y. Okay. Okay, so I've got 9,000 equals 730. Oops, 731 plus 0.35 raised to the T. I have to find T, right? If this is my Y, what do you think all of this is going to be in my calculator? X. Okay. So what I'm going to do here, when I have to look for Y or find Y value, I'm going to look for the X value when Y is 9,000. So whenever I'm looking for T, I have to put this in my Y equals. It's going to be important later. Remember that. Okay, so in your calculators, I have to put this in my Y equals. Okay, so my Y equals 730 times parentheses 1 plus 0.35. And I don't have a T, but I have an X key, right? So I'm going to put X. I'm going to graph it. See my calculator working here? It's like the Windows Forever thing, spinner. All right, it's done. Done calculating. It's graphed it. I don't even care what the graph looks like. I'm looking for that Y value of 9,000, right? Right? So I'm going to go to my chart. And I'm looking for the Y value of 9,000. Oh, there's 10,000. There's 8,000. So what's my X value? Yeah, between 8 and 9. So let's put that down for our answer. Between 8 and 9. Did you get that? You know how to do that? It's really actually kind of complicated. When you're looking for the T, put this in your Y equals and look for the Y value 9,000, and that's your answer for X. Okay, let's do another one. We did. It says how many minutes? Well, it's between 8 and 9 minutes. I'm not going to find the exact one because You guys will do that in college algebra and beyond. Okay, let's go. When you buy a car for $36,000, what's that? That's my initial amount. $36,000 for a Prius. A Prius will cost you $36,000. Prius. Prius. Okay, the Y value of the car decreases, so I have a decay. So 1 minus my rate, 14%. We don't like percentages, we use decimals. 0.14 each year. Write an exponential decay model of the value of the car. So Y equals 36. So I need a T here, right? So there's my model. Right? There's my model. I wrote a model for the depreciation. What the hell? Actually, it feels pretty good. Ooh, I'm recording on it. Estimate the value after 3 years. So what does that mean? T. So T equal 3. Okay. Now I have the value for T. Do I have to put this in my Y equals? No. I just plug in T to find out Y. So I'm going to use Y equals 36,000. 1 minus 0.14. This time I know what T is. It's 3. Because I have no variable on the right-hand side, I can just plug this into a calculator and get a number. Calculator. Bet it's somewhere around 22,800. I did this 3 times already. That's right. Now you're getting the hang of it. 22,800. Like I did this before. So there's a value of the depreciated car. So your Prius costs $22,898.02 now. C, craft model on your calculator. So here's my model, right? Here's my model. It says graph model on your calculator. So where am I gonna put this? Yes, where in the calculator? The Y equals, because I have a variable here on the right hand side. Hey, look at that. I think I might already have this. No, I don't. That's too bad. 36,000. 36,000 times 1 minus 0.14 raised to the x, because I don't have a t. And then it says estimate the car when it will have, so this is my y. And I'm looking for my t, right? Okay, so now I have to graph this. It's working, okay, graphed it. I don't care what it looks like. I'm looking for my y equal 15,000. And it's between what? 5 and 6. So between 5 or 6 years. Last one. The growth of an antique table's value in after 1975 can be represented by the equation A equals, again, I hate the A because we've been working with Y, equals 325 times 1 plus 0.03 raised to the T. What's the value of the table in 1975? Now, this is really kind of confusing because it's less than a year here, right? So what does T equal? Well, it could equal 0 or it could equal 1. I'm going to use 1 because if it's 0, it's 325. So I'm going to put in 1 because I'm assuming that's what they want us to use with this poorly written problem. So I'm going to use y equals 325 times 1 plus 0.03 raised to the 1. And put that in your calculators. You're going to get 384. 334.75. So that goes here. Now it says, what's the rate of growth? Well, we only have two numbers to deal with here. Right? It grew by how much? Well, I don't know. Let's just minus 325 because that was our initial cost. And we get $9.75. So I'm assuming that's what they're looking for the 1 year rate of growth. 325. And you know what? Still comes out to $9.75. Questions, comments, concerns? Now, you've got like 20 minutes here, a little under. You need to work on your homework. Okay, so I'm assigning these 4 problems today. But more importantly, what should you do if you need to finish a quiz? Finish the quiz. Either or, I don't care. But, you should not be playing video games. What? One what?